4-6 probability. The proper meaning of probability is the chance of something's happen or the chance of something's not happen. So if we are sure something's not going to happen, we call it the zero probability. The probability is 0, or you can say 0%. But if you 100% sure, so if you're 100% sure it's certain happen, so we call it 1 as a number, or 100% as a percentage. So any things happen or not happen, the probability is all the time between 0 and 1. If it's 0, not going to happen. If it's 1, it will happen. Or if it's between 0 and 1, so if it's between 0 and 1, there is a chance it's happened. If it's 0.5, so that's 50% chance. If it's less than 0.5, it has less chance to happen. If it's more than 0.5, so this side, it has greater chance to happen. So a probability, it will happen or not happen. So we can say probability of some event happening, or plus probability of not, so let's say complementary, not going to happen, complement. So something's happen or not happen, together it's going to be 1. 100%, or it will happen or not happen. So happen or not happen is all time, total is 1. Give the probability for each outcome. So when we talk about a probability, so we are going to chance of something's happen. So when you spin the spinner, that will turn spin around and land on a color. What is the probability of red? As you see, it's half of the circle color with red. So 1/2 or 0.5, so 0.5 is going to land on the red. So the probability of red equal, we have 2 parts from all, 1, 2, 3, 4, 2/4. So that's equal 1/2, that's equal 0.5. Sorry about that one, that's equal 0.5. What about yellow? We have only probability of yellow. Let's say we have only 1 sector yellow, so 1 over, in the total we have 4 sector, 1/4. So we can say it's 0.25 chance. 1/4, 0.25, so 0.25. And blue is the same as yellow. Blue and yellow has the same area of the sector. We can say 0.25. So in the total, when you add all of them, it's all time equal 1. So that's 0.5. If you add these 3 probability, any of them can be happen. So 1. 0.5 plus 0.25 plus 0.25. It's equal 1. So 100%, when you spin the spinner, it will be stuck on red or yellow or blue. So when you add all this probability, it's equal to 1. Let's continue. A game consists of randomly selecting 4 colored cubes from a container and counting the number of green cubes. The table gives the probability of each outcomes. So what is the probability of selection at most 1 green cube? So at most 1 green cube, it can be 1 or 0. So these 2 is asking about these 2. So what can I say? Probability of 0 or 1. So 0 or 1. You can add probability 0 plus probability 1. This is the question. So probability of 0 is 0.043. 0.043 plus probability of 1, 0.248. 0.248. It's equal 8 plus 3, 11, 9, 2. 0.291. This is probability at most 1 green card, at most 1. That's the first question, answer of the first question. So if it say at most, that means it can be 0 and most 1, not greater than 1. What is the probability of selection more than 1 green? If it say more than 1 green, that means 1 is not included. It must be greater than 1. So it can be 2. Let's change the color here. It can be 2 3, or 4. So any of them, probability of them, that means you need that or these 3. Probability of more than one green, so it's equal, I need that probability of 2, probability of 3, and probability of 4. Let's say probability of 2 plus probability of 3 plus probability of 4. So let's say 0.418 plus 0.248 plus 0.043. I think that's a little small, it's not visible. Let's write it again. So let's say that's equal 0.418 plus 0.248 plus 0.043. 8 plus 8, 16 plus 3, 19. 1 plus 4, 5, 9, 10. 4, 6, 7, 4, 6, and 1 more, 7. So that's equal 0.709. That's the probability of more than one green cube. Let's continue another example. The weather forecast calls a 60% chance. So the rain percent is 60%. Give the probability for each outcome. If it's going to rain 60%, so rest of it not rain. So no rain will be 40%. What is the rule? Probability of rain plus not rain. Probability of not rain. It's not going to rain. It must be equal 100%. It's equal 1, but as a percentage we can say 100%. If this is 60% plus probability of not rain, it's equal 100%. I can say probability of not rain equal 40%. 60% you can take away from both sides. So 100 minus 60 makes 40%. That's the basic of probability for the 9th grade. Let's continue from experimental probability. Okay, 4.7 experimental probability. Experimental probability, when you do an experiment, you need to count number of times the event occurs, and you need to divide the total number of tries. You will try some things, how many times it's happened and how many times did you try. That's our question. So let's see one example. After 1000 spins, so in the total we spin this spinner 1000 times. The following information was recorded. So its length 448 times blue, 267 times red, 285 times yellow. Estimate the probability of spinner landing on red. So what is my probability? They're asking about color of red. It's land on the red. So if you check the table, it's land on the red 267 times. 267 over total try. How many times we try? Thousands, over thousands. So that's equal 0.267. So for the next spin, the probability of the spinner going to land on the red is 0.267. A game spinner was spent 500 times. So we spent 500 times. 500 times. It was found that A was spent 107. So A 170. B was 244 times. C 86 times. C is 86 times. Estimate the probability that the spinner will land on A. So probability of A. How many times we get A is 170 over how many spin in total? 500. So to make it decimal, I'm going to enlarge by 2. That's equal 340 over 1000. That's equal 0.34. 34% the chance. 0.34 is the probability it's land on A. Okay, another example. So when we talk about experimental probability, we do some things, we try some things, and we record the results, such as that one. A card was randomly drawn from a bag and then replaced. So when you draw a card, you put it back. Be careful here. If you don't put it back, the number of cards will decrease. That's another topic in probability. A card was randomly drawn from a bag and then replaced. After 300 drawn, so we draw it 300 times. It was found 45, that's yellow. 76, oh, sorry, 7 wasn't good, clear. 76 is red. 92 blue. 87, oh sorry, that must be green. 87. So estimate the probability of drawing a green card. How many green? 87. 87 over 300. That's the probability. 7 divided by 300, it's equal 0.29. That's the probability of, I forget to write it here, probability of green. Probability of green is equal 87 over 300, 0.29. That's the last example. Teacher polled 113 students about the number of siblings they have. Use the table to compare the probability. A student has one sibling, so only one, sibling, and probability of two siblings. Okay, as you see, we have 45, so students has one sibling, and 27 has two siblings. Of course, for one sibling has more than two siblings, so that's the probability of one sibling greater than the probability of two siblings. Compare the probability that a student has no sibling. So 14, let's change the color about that one. 14 student has no sibling. The probability that has students has three siblings. So 15. 15 is more than 14, so you can say probability of no sibling is less than probability of three siblings. That's how we compare which one has greater value. It has the more chance, of course. That's how we compare the probability. After that one, next section is about theoretical probability. For a theoretical probability, we cannot separate the topic of probability, so I don't want to separate two. When we talk about theoretical probability, the probability of each outcomes is 1 over n. So if suppose that n equally likely outcomes in sample space, such as what? Rolling a dice. Why? There are 6 equals phase. So probability of rolling any number. So let's say 1. So there are 1, 1 and out of 6. So 1 over n, we have n space. Probability of 2, same idea. We have only 1, 2 on the dice. So one number of 2 is 1 and out of 6. What is the probability of an event is number of outcomes in the event. So divide by number. Laws of mutual exclusive. So if A and B are two mutual exclusive disjoint events, then A and B, if we are asking A and B, the probability all time 0. Such as what? Rolling a dice. Let's say rolling a dice 5 and even number. If you roll a dice, 5 and in even number cannot be happen anytime. It can be 5 or an even number maybe, but not 5 and even number. In the same time, our dice cannot become 5 and even number or 5 and 1, no problem. So it's all time the probability of this is happening 0. Probability of A or B. So if not A and B, if we are asking probability of 5 or even number. Even number, yeah, that's okay. Then we need to add the probability of both. So what is the probability of 5 plus probability of even number? Let's say probability of even. What is the probability of 5? We have only one 5, so 1 over 6 plus how many even numbers on dice? 3, 3 over 6. 1 plus 3 is 4 over 6. That's equal 2 over 3. That's nearest equal 0.66, so or 0.6 is repeating. It's exactly equal 0.6 is repeating. So that's a rule. If there is an OR, we add two given things, but if it's AND, it cannot be together, so it's equal to 0. Okay, an experiment consists of rolling a fair number cube. So when we talk about number cube, so there are numbers 1 to 6 on it. Find the probability of each event, odd numbers. So on a cube, we have 1, 2, 3, 4, 5, and 6. Total we have 6 elements. How many of them odd? 1, 3, and 5. There is 3 elements, and the probability of odd, how many odd? 3 over, in the total we have 6 elements, 3 over 6, 1 over 2, this is equal 0.5, 50% chance. 2 or 4. The idea 2 or 4, so I need to calculate probability of 2 plus probability of 4. That's 1 over 6, because we have only 1, 2, and plus 1 over 6 again, it's equal 2 over 6. You can solve this one like that, another way. Again, we have 1, 2, 3, 4, 5, and 6 on the cube. What is the question asking? 2 or 4. It can be 2 or 4. As you see, there are 2 elements. So number of this set 2, probability of 2 or 4. There are 2 elements over, there are 6 elements. 2 over 6, 1 over 3. That's equal 0.33 repeating. So that's equal 1 over 3. That's equal 0.3. That's 3 is repeating. Okay, let's solve some more questions. Example, an experiment consists of rolling 2 fair number cube. Find the probability. When you roll 2 fair cube, number of sample space, so how many possible outcomes occur? 36. 6 times 6, 36. Total shows 3. So which elements show 3? 1, 2, and 2, 1. So that's probability of the total equal 3. How many different way? 1 and 2. We have only 2 elements out of what? 36. That's equal 1 over 18. At least one even element. So that's a good question. At least one even. It can be 2 even or 1 even. So if you write all possibilities 1, 1, 1, 2, 1, 3, 1, 4, as you see, odd numbers, if you take away only odd numbers, it will be easy. So 1, 5, 1, 6. 3, 4, 1. So 5, 1, 5, 3, and 5, 5. There is no even number. And 3, 1, 3, 3, 3, 5. Only 9 element doesn't have any even numbers. All the others at least has one even number. So I have 36 elements. If I subtract, take away these 9, 27 elements left. So probability of at least one even, that's equal, I have 27 of that over 36. So 27 over 36, it's equal 3 over 4. 0.75. Let's go 0.75. You can solve others. Total shown bigger than 0. So all of them greater than 0. When you roll a dice, all of them greater than 0. This will be 1. Total show less than or equal to 9. That's your question. You can try to solve that one. Next. That's a good question. Again, a deck contains 20 red cards, 25 blue cards, and 15 red cards. So in the total, I have 20, 45, 50, 60. 60 total. 20, red, 25 blue, and 15 green. How many yellow cards must be added? So I will add yellow cards. At the moment there is no yellow card. Toolback, so that the probability of drawing a green card is 1 over 6. So this question asking probability of green going to be 1 over 6. But after adding yellow, how many yellow? Number of yellow. Let's say this is number of yellow. Now my total change. Why? At the moment it was 60. New total equal 60 plus number of the yellow. So what is the probability of green? Probability of green. I didn't change green value of green. So what is the green? 15. 15 over 60 plus number of the yellow. That's equal 1 over 6. So if these two are equal, you can cross multiply it. 60 plus n multiply by 1 equal 6 times 15, so 90. 6 times 15 is equal to 90. So 60 plus n equal to 90, n equal 30. So if I add 30 yellow card, 100% sure it's going to be 1 over 6. The probability of green will be 1 over 6. Be careful, we add the yellow. Oops, sorry about that one. Let's mark that here, and that's okay. We add yellow, so the number of green didn't change here. If you add green, so you need to add here green too. Okay, next. To win a prize in a game, you have to roll 2 fair dice and get the total of 9. To win, you need to get total of 9. To play, you have to get total of 3. What is the probability of winning or replaying? Be careful, it's winning or replaying. Probability of winning or replaying. That's equal probability of winning plus probability of replaying. Now, it says total is going to 9. If the first dice is 1, it doesn't make any 9. There is no 9. Sum of it cannot be 9. If the first dice is 2, I cannot put any number. If I put here maximum 6, it's going to be 8. If the first dice is 3, I can say 6. If the first dice is 4, the second dice can be 5. The first dice 5, second dice can be 4. If the first dice 6, the second dice can be 3. How many difference value? 1, 2, 3, 4. I can't roll any of these, so I'm going to win. Let's say probability of win. So probability of win 4 over how many outcomes when I total outcomes when I roll 2 dice? 36. 6 times 6 is 36. Plus replay. So to replay, let's use another color. I need to roll, the total must be 3. 1 and 2, 2 and 1. There is only 2 options. So 2 over 36. 4 over 36 plus 2 over 36 is equal 6 over 36. 1 over 6. And 1 over 6 it's equal 0.16, and the 6 is repeating. That's the end of this video. Okay, there's a spinner, but directly you can say the probability of theoretical probability is blue is 0.25. So one. Let's choose that one to write on the screen. That is okay. That's 1 over 4. That's equals 0.25. When we talk about theoretical probability, the probability of 1 is 1 sector over 4 sector. 1 over 4, 0.25. Again 0.25, again 0.25, again 0.25. So these are the theoretical probability. We didn't do anything. We didn't spin. So it's, as you see, all times 0.25. Sorry. So you can write all probability, blue, pink, gray. It's all time 25% chance. Let's spin it. Let's spin it how many times? Let's spin 1, 2, 3. I will make it here 20. I already spin it 20. I say 3 times. I already spin 23 times. Let's make more 27 spin. Number of spins 27. It's in the total. It will be 30. Now I get 30 spin. As you see now, It land on the blue 5 times, pink 10 times, gray 6 times, orange 9 times. What is the total spin? 30. You can see from here. Let's make the zoom a little on that one. Yeah, that's better now. Okay. Now, as you see, theoretical probability is 25%. Again 1/2, but when you calculate the next turn, the chance of blue is 5/30. The chance of pink, 10/30. The chance of gray, 6/30. The chance of orange, 9/30. The theoretical probability, experimental probability. But I want to spin it 10 more time. When you spin 10 more time, so as you see, the numbers change. 11 orange, 9 gray, 12 pink, and 8 blue. For the next turn, again, probabilities change for the experimental. It's become 20%, it's become 30%, 22.5%, but theoretical doesn't. Theoretical, it's all-time constant, but spinner, when you spin one more spin, now it stops. I make 10 more spin actually because of it's written here 10. Now blue become 20%, pink become 28%, gray become 26%. Let's more. I will want to make only one more spin. Let's see. It stop on the blue. You see the probability of blue change, and all of them change because total is changing. Let's spin it one more time. Now orange 26 increase, others decrease. One more time. Pink. Now pink increase, others decrease because the total is changed. So when you spin it more, you get more result, and all time experimental probability change for future. Another. So theoretical probability all time 25%. Interesting fact here, when you spin it more times, as you see, the experimental probability all time get closer to near to theoretical probability. Let's start new experiment. Let's start 10 times. Let's spin it 10 times. Spin. Now 20, 40%, 30%, 10%. New 10 spin. 15, 45, 30. Again change. And so more spin, different result. But theoretical is not. Experimental is about doing something. Theoretical, it's about the values. Thanks for listening. Sorry about this long video, but I don't want to separate probability, different videos. That's end of this video. Thank you for listening.